unable to match the speed of its orbit. Some genuinely strange results arise from this peculiar circumstance. The sun's gravitational pull has slowed Mercury's rotation over billions of years. But why does it rotate so slowly? This is as a result of tidal locking to the sun. Saying that Mercury is tidal locked to the sun means that the planet's rotational period, the time it takes to rotate once on its axis, is synchronized with its orbital period, the time it takes to orbit the sun. Which means the same side of Mercury always faces the sun at perihelion, closest point to the sun. The opposite side of Mercury always faces away from the sun at aphelion, farthest point from the sun. However, Mercury is not perfectly tidally locked. Scientists believe that Mercury is in a phenomenon known as a 3-to-2 spin orbit resonance, which means that it rotates 3 times for every 2 orbits around the sun, in contrast to our moon, which is completely tidally locked to Earth. The impacts of Mercury's unique day-night cycle are severe. The side facing the sun bakes in great heat for months at a time, while the night side stays in a freezing darkness for an equally long period of time, thus leading to some of the most extreme temperature variations in the solar system. Secrets of the planet. When discussing Mercury's atmosphere, or lack thereof, it's important to remember that the planet's meager atmosphere is referred to as an exosphere. Numerous processes regularly lose and replenish this extremely thin layer of gases to space. Mercury's fragile exosphere is sustained in part by the solar wind, radioactive decay, and even micrometeorite impacts. Observations conducted recently have uncovered some unexpected elements in Mercury's exosphere. Using data from the MESSENGER mission, scientists found in 2020 that there is more water vapor in Mercury's exosphere than previously believed. It is thought that the combination of oxygen in Mercury's surface rocks and hydrogen from the solar wind produces this water vapor. It is thought that the combination of oxygen in Mercury's surface rocks and hydrogen from the solar wind produces this water vapor. Mercury's long day and short year have an interesting effect on the planet's magnetic field. Mercury possesses a worldwide magnetic field, which startled scientists when they initially noticed it despite its small size and slow spin. According to recent research, Mercury's magnetic field is produced by a special dynamo effect in its liquid metal core, which is fueled by the planet's unusual rotational and orbital properties. Another intense secret of Mercury is its unexpected magnetic field. Unlike Venus and Mars, which have no global magnetic fields, Mercury's magnetic field, despite being far weaker than Earth's possessing just 1% of the Earth's magnetic field, is essential in shielding the planet's surface from the intense solar wind. Without it, Mercury's meager atmosphere would be destroyed even more quickly by the solar wind. Scientists were surprised by this discovery discovered by NASA's MESSENGER mission since they didn't think a small planet with a sluggish rotation could sustain a magnetic dynamo. A team led by planetary scientist Dr. Katherine Johnson of the University of British Columbia discovered something even more unexpected concerning Mercury's magnetic field. They found that the field is located approximately 20% of Mercury's radius away from the planet's center. Variations in Mercury's crustal thickness may be the cause of this offset, as they impact the planet's inner heat flux. Additionally, there are some intriguing observational opportunities due to Mercury's slow rotation and fast orbit. The sun appears to stand motionless in the sky at certain times near certain hot poles, which are specific locations on Mercury's surface. The planet's most intense heat is felt at these hot poles. Conversely, certain regions close to Mercury's poles receive no sunlight at all. Water ice has been found in permanently shadowed craters on Mercury's poles, which is one of the most fascinating recent findings about the planet. Dr. Nancy Chabot participated in this study as well. Researchers have discovered indications of water ice in these areas that are permanently shaded. However, on a planet this near to the sun, how can ice survive? It's all because of Mercury's distinct rotation and orbit. Even if the surrounding areas burn in the sun's heat, the permanently shadowed craters on Mercury's poles remain extremely chilly because they never get direct sunlight. Scientists are now wondering if any other volatile materials, such as organic chemicals, could be kept in these cold traps in light of this discovery. Mercury's lengthy day and short year have an impact on how we study the planet. Reaching Mercury is difficult for spacecraft because of its rapid orbit around the Sun. To slow down sufficiently to enter an orbit around the planet, they must perform a series of intricate maneuvers, such as repeated flybys of Mercury and Venus. These gravitational pulls will help the Bepi-Colombo mission, which is presently traveling to Mercury, gradually modify its course and speed. The spacecraft was launched in 2018, but it won't reach Mercury's orbit until 2025. That is, after 9 planetary flybys. Bepi-Colombo will encounter additional difficulties after entering orbit because of Mercury's peculiar day-night cycle. The spacecraft will have to balance keeping electricity throughout the long, chilly nights with carefully controlling its exposure to Mercury's strong daytime heat. This fine balance, which emphasizes the harsh conditions brought about by Mercury's particular spin and orbit, is essential to the mission's success. New insights into how Mercury came to have its current rotation rate have been revealed by recent computer simulations. According to these simulations, Mercury may have originally rotated far more quickly before being slowed down by the gravitational pull of the Sun and huge asteroids or comets. This study contributes to our understanding of the evolution of not only Mercury, but also other planets in our solar system. As we continue to study this planet, new questions arise like, how does the planet's core remain partially liquid despite the long nights and extreme cold? What impact has Mercury's peculiar orbit had on the formation of its geology? These inquiries serve as a reminder that there are still a lot of unanswered issues about our own solar system. Because of Mercury's distinctive features, we are forced to reevaluate current beliefs and consider novel avenues for inquiry into the formation and evolution of planets. Mercury's hidden depths. Mercury harbors more mysteries as we have been revealing. Mercury still confounds scientists with its peculiarities and surprising properties despite its size. The extraordinarily huge core of Mercury is one of its most fascinating secrets. A study performed by planetary scientist Dr. Nancy Chabot of the Johns Hopkins Applied Physics Laboratory found that around 85% of Mercury's bulk is made up of its core, compared to the Earth's core, which makes up only 15% of the planet's volume. This is far larger. However, why is Mercury's core so massive? According to one idea, Mercury was previously considerably larger and was destroyed in a major impact early in the solar system, losing most of its outer layers. This concept, referred to as the hit-and-run scenario, was put forth by a University of Arizona physician, Dr. Eric Asfog. This idea suggests that Mercury may have been struck by a giant planetesimal that removed much of its crust and mantle, leaving behind the iron-rich core that is visible today. The puzzles, however, don't end there. Sulfur, potassium, and sodium were among the volatile components found on Mercury's surface, according to a 2020 scientific announcement. Finding these elements on a planet this near to the Sun was surprising because they usually evaporate quickly at high temperatures. Dr. Patrick Poplawski of the Johns Hopkins Applied Physics Laboratory proposed that comets or asteroids may have transported these volatile elements to Mercury, subsequent to the planet's formation. Mercury's craters contain signs of organic substances, according to scientists. These so-called dark deposits may consist of intricate carbon-based compounds, akin to those that may have been involved in the emergence of life on Earth. Could there be hints about the origins of life in our solar system on Mercury, despite its hostile environment? Unexpected geological activity on Mercury is another dangerous mystery. For many years, geologists believed that Mercury was a lifeless planet. Messenger mission data, however, showed signs of very recent volcanic activity. On Mercury's surface, Dr. David Rothery of the UK's Open University discovered little, brilliant dots that seem to be volcanic vents. Known as hollows, these characteristics imply that Mercury might be geologically active even now. Mercury's chaotic terrain, a sizable region of disorganized hills and valleys close to the planet's south pole, is one of the most perplexing aspects of the planet. This region, roughly the size of Texas, was originally seen by the Mariner 10 mission in the 1970s. According to a theory put out by Dr. Thomas Waters of the Smithsonian Institution, as Mercury's orbit changed